US Physics Olympiad, year 2019, F equal MA. First round, Exam A. This year, in competition, students can choose either first day Exam A or another day Exam B. For each exam, they had 25 problems, and for 25 problems, they had 75 minutes. To get more interesting problems, you could subscribe this channel. Problem number 1. A coin of mass m is dropped straight down from the top of a very tall building. As the coin approaches terminal speed, which is true of the net force on the coin. Solution for problem number 1. Before the coin reaches terminal velocity, it is still accelerating downward. So there must be a net force downward on the coin. However, because the coin has a non-zero speed, there is a drag force opposing its motion downward. So the drag force is acting upward on the coin. The only other force acting on the coin is mg downwards. So the net force on the coin must be less than mg in magnitude. That was answer C. That was a solution for problem number 1. Problem number 2. A mass of 3m moving at speed v collides with the mass of m moving directly toward it, also with speed v. If the collision is completely elastic, the total kinetic energy after the collision is Ke. If the two masses stick together, the total kinetic energy after the collision is Ks. What is the ratio Ke over Ks? Solution for problem number 2. In first case, we have absolutely elastic collision. It means that energy is not losing, and we can count what is kinetic energy before collision. That will be kinetic energy after collision. So that will be 2mv square. In second case, we have absolutely inelastic collision, and we have to find what is speed of center of mass. That will be speed of two masses moving together. This is how to count what is speed of center of mass. That will be 1/2 v. And now we can count what is Ks. Ks equal this expression, which is 1/2 mv square. And now we can count what is the ratio. The ratio Ke over Ks equal 4, which is answer E, and this is the solution for problem number 2. Problem number 3. A block of mass m small is launched horizontally onto a curved wedge of mass big M at a velocity v. What is the maximum height reached by the block after it shoots off the vertical segment of the wedge? Assume all surfaces are frictionless. Both the block and the curved wedge are free to move. The curved wedge does not tilt or topple. Solution for problem number 3. First of all, here we can use energy conservation and momentum conservation. This small block will reach highest position when speed of this block will be equal to speed of this wedge. It means that we can find what is this speed of center of mass of these two blocks when they move with the same speed. That will be this expression. And now we can write energy conservation. So we have initial kinetic energy for the first block equal kinetic energy of two blocks together plus mgh. So that's the equation from which we can count what is h. When we put the expression for V center of mass, we will get this equation, and after that H equal this value. That's the answer E, and that was a solution for problem number 3. Problem number 4. A massless spring hangs from the ceiling, and the mass is hung from the bottom of it. The mass is supported so that initially the tension in the spring is 0. The mass is then suddenly released. At the bottom of its trajectory, the mass is 5 cm from its original position. Find its oscillation period. Solution for problem number 4. Here we can use energy conservation, because if we take this mass and release it, it will go to a point where whole potential energy of gravity moving to potential energy for stretch spring. So that will be 1/2 kx square equal mgx, where x is 5 cm. From here we can find that mass over spring constant equal x over 2g. But the period of oscillation equal to pi multiplied by square root from m over k, all that's equal to this expression. Now putting numbers, we will find that period equal 0.31 seconds, which is answer C, and that was a solution for problem number 4.